Hello there, we will talk today about RSA, which is a cryptography algorithm. It's a very important algorithm in cybersecurity, and we should learn about this. I will begin to explain this with an example. We have two persons, Bob and Alice. Suppose Bob want to send a message to Alice, which, for example, x equal 42. This is the message. Bob want to send it to Alice. Okay. Bob should be sure that the message will be safe and not a third person, for example, take this message and open it and can read it. That's why we should crypt this message in a safe way. Okay, for RSA, Alice should first do the first thing. Alice should start in preparing for the message to get the message. What should Alice do? Alice should choose two prime numbers. Let's suppose B and Q. This is prime numbers. Okay. For example, B equal to like 11, Q equal to 13. Okay, this what Alice chose. Then Alice should calculate n equal to p q. Okay, b multiplied with q is 11 and 13, and it's like 143. Okay, this is the second step. Okay, the first step is to choose B and Q, the prime numbers, and the second step is to calculate N. The third step, Alice should calculate phi N. Phi N is BQ, then phi PQ, and this is okay because B and Q prime numbers, then we can say phi B multiplied phi Q. Okay, if you want to know more about phi, let me know in the comments. I can do another lesson about phi. Okay, now phi B is a prime number. Okay, because B is a prime number, we can say phi B is B minus 1. Phi Q is prime number 2, then phi Q is Q minus 1. Okay, B minus 1 is 10 multiplied by Q 13 minus 1 is 12, and this is 120. This is okay. Now Alice calculated phi n and choose B and Q. Okay, the next step, Alice should choose E. E is a number should greater than 1, and there is a condition which is GCD, the greater common divisor, GCD A and phi n must be 1. This is very important. Okay, and because phi n is 120, Then we should choose E as a prime number, for example, and this is better. We can choose, for example, 7. E. Alice choose E as 7. Okay, and the GCD 7 and 120 is 1. And this is very important. Now we have B and Q, we have N, we have phi N, and we have E. And now we have this public key. Public key is NE, which is N 143 and E is 7. Okay, this is the public key. Alice can publish this to the world. It's okay, it's no problem. Now Alice should calculate the S. S is the secret, is come from secret. This is very important. And how can Alice calculate S? There is like equation E multiplied S is concurrent to 1 modulo phi N. E is 7 S concurrent to 1 modulo phi N. We calculated N is 120. Okay, how can we calculate S? We should calculate S with extended Euclid algorithm. And this is very important to know what's the value of S. Okay, we can do like this. This is 120 and this is 7. 120 is 7 multiplied with we should find the number, and this number, when we calculate with 7, we should get 120 or less. We can do this with, for example, 770, for example, 27. Okay, it's like 87. Okay, it's 70. Okay. When we multiply 70 with 7, we get 120. Okay, then we multiply 7 with 70, and the remainder is, or the remain is 1, because 100 and 120. Okay, now 1 is equal to 100 minus 70 multiplied with 7. Now the number before E, which 7, is the S. This is the number. And the S is the minus 17, but we don't want S to be negative. We want it to be positive. We can do it E is 7 multiplied minus 17 concurrent 1 modulo 120. We can just 120 minus 17 is 103. 7 multiplied 103 is equal to 1 modulo. Okay, then S is 103. This is S. Now we have the secret number. It's very secret. Alice doesn't allow to publish this to the world. Now we have the public key. Public key is 143 and 7, and the private key is 103, and N or E is 7. Or no, 100 N is 143. Okay, this is the private key. This is very geheim or secret, yeah, top secret. Okay, now we are done with Alice. Alice made all the preparation to get this message from Bob. Now what should Bob do? Okay, now can Bob encrypt the message. The message is 42. Bob can do this in this equation. Y is 42 or X with the power E mod N. Now Y is X is the message is 42 in the power of 7 modulo, and we have N 143. Now when we calculate this need to a lot of calculations, and it needs time, but the result is, we can find the result. The result is 81. This is the encryption message, or the encrypted message. We transfer this X to Y, which 81. Now Bob can send this message, not this message. Bob can send Y is 81, the encrypted message, to Alice. Okay, now what should Alice do? Alice should de-encrypt this message to get X, the original message. How can Alice do this? Alice can do this in this equation. X is Y power S, the secret, modulo N. And this Y is 81 power S. What was S? Is 103 modulo N. What was N? 143. and this is, what's this? Okay, we should know this without calculation because this is the original message. When we de-encrypt the encrypted message, we should have 42. Okay, if you get another result, then we have an wrong or something like that. That's why it's important to make sure that x is 42, and we are done with this. And it's the RSA encrypted algorithm or encryption algorithm. And this is very important in cybersecurity, and I hope you understood the lesson. And very sorry about my English. My English is not so good, but I hope you get the idea. Okay, now if you like the video, please leave a comment and like to the video, and ciao.